Good morning, everyone. My name is Kelly Paffel. I'm with Swedgelock, and I oversee the steam system engineering and analysis, auditing, and also with the compressed gas work that we do for leakage correction. And today I want to talk about steam and condensate leakage and what I call a management program. The thing about what we call a management program, you go out and you find a leak and make a correction. That's only one part of the step. The next part is analyzing what caused the failure, which is basically root cause analysis, and determining what changes need to occur in the system to prevent leakage. What I tell plants, and doesn't matter what size, very small, very large, I'll allow you maybe 2 steam leaks a year, period. There's no reason to have more than 2 steam leaks. And as I go through this presentation, I'll kind of describe things that we can do today to stop leakage. There's no reason to have steam leaks. So this is a vital point. Just don't go out and fix the leaks and then expect it not to leak again. You got to do root cause analysis. And it has to be part of the management program. It really, really does. You have to understand failure. And once you understand failure, make changes to improve the system. And change has to occur from design, installation, selection of products, vendor selection. Change has to occur. So the thing is that just don't go out and fix leaks because the leaks will come back again. So make changes. Don't accept leakage as normal. It's abnormal. I've been in very, very large plants that have 4 steam leaks and think that is outrageous. I've been in plants that have 400 steam leaks and don't think anything about it. So make it a normal not to have steam leaks and abnormal to have it. So I have a screen here. Just give me a second. Up to the side. Okay. Energy losses from steam and condensate. I can go on for a long time regarding that. You know, I've been in plants that have been as high as 19%. That's an extreme. You know, the fuel budget is $1 million and the steam leakage is $190,000. But that's extreme. But it does add up. It really, really does. And the emissions add up too. So that's why we have to be proactive. You know, the thing is, we talk about compressed air. A steam leak is $3,591, 100 psi, 1/8 inch leak, $10 per 1,000 pounds. Compressed air is $2,095. Just a comparison of leak cost. The thing about steam leakage, if I go out and fix a steam leak, I'm guaranteed an instantaneous savings. And that might not be true of compressed air. And compressed air, we fix leaks, we have to shut compressors down to achieve the savings. Not to disregard compressed air, we need to do correction. It's just saying, you know, what the cost difference is there. The thing that when it comes down, it comes very, very difficult to estimate the losses through a steam leak. The thing is that we can estimate the size of the leak diameter and the steam pressure on that one side is P1, and usually the downstream is always atmospheric, which is P2 or 0 pressure. Oh, right. So a basic of leak is P1 from the high pressure to P2. If you have a given orifice, it's not a problem. All you have to do is a Napier's conversion. The problem with this is the leak is never a perfect orifice. Never a perfect orifice. So it's really, you can't really do an orifice calculation because the leak is not a perfect orifice. So therefore, we have to use a constant to be used in the equation for compensating for that. For a saturated steam system, we use the temperature to determine the steam pressure. If we don't know the pressure, which is P1, through the jagged leak, which is P2, which is 0. The other thing is the emissions. This is from the EPA, and I was with the STEAM committee for many, many years with the Department of Energy, and I have lots of this information available when I was on the committee, and this is just the pounds of CO2 for the different fuels. And we can cross-check that with steam losses, which I'll show you here in a minute. And the other thing people always ask me about estimating steam loss by the plume leak. It's not very accurate. There's no engineering data for these estimates. It's all subjective. The only thing is that we need to stop leakage. So the steam loss calculations of variance is 22.88 times P atmospheric, or absolute, times diameter square. And basically you come up here and you put it into here, the pressure is 100 psi. The steam loss through a 1/8 inch leak is 41 pounds per hour. Cost per hour is 41. Days per year is 365. So it comes up to $3,591 per year. And this information is available. All you have to do is email Jennifer, and I can provide you this information. A 3/8 inch leak, can be as high as $32,000 a year. That's a 3/8 inch leak. It's a pretty significant leak, okay? Not to say we don't have them out there, but it's a pretty significant leak. Roadmap for steam condensate leakage management. Number 1, institute change. If you're ready for change, life is really good. If we're just going to go out and correct steam leakage without making change, I would say it's not very fruitful. You're going to get the leakage to come back. Number 1, you have to sit down, institute change. These are the things that we're going to do, and it comes from all aspects, from purchasing components, installation, design, a multitude of things. Then go out and correct all the steam and condensate leaks. After all that's been done, validate the changes were successful, that the leaks did not come back. So if I went out there and fixed 20 leaks, 6 months later, they're still not leaking. So I validate that the changes were successful and let people know that the changes were successful and we did do the correct thing. Today's steam operations, this is what I wanted to see. 0 leaks. The other thing I want to see, 0 steam loss to atmosphere. So the standard, and I go overseas all the time. I was just working on my trip. I'm leaving here shortly to go to Asia. And I've been in plants in Thailand. So I walk through the plant and maybe see 1 steam leak. And I see 0 steam loss to atmosphere. They don't vent steam to atmosphere, which I find fantastic. That is the way it should be. So today's steam system operation, when you come to your facility, just like this picture here, this is what I want to see. No steam leaks. No steam loss to atmosphere. That is the standard for today's steam system operation.